Carbon dioxide frost has been measured near the Martian equator within a single Martian night, forming after midnight and gone again at sunrise on a planet famous for dry ground. What exactly freezes out of the Martian night air, and why is most of it gone before the surface looks familiar? The answer starts at sunset, not at the poles, but at the surface itself. Mars has air, but not much of it. The pressure at the ground is usually less than 1% of Earth's sea level pressure. That thin air cannot store much heat, and it cannot return much heat to the soil after the sun drops. The ground radiates energy into the dark sky. Rock, dust, and ice cool quickly. Near the surface, the air follows. InSight measured this daily violence in ordinary weather. At IH-Liz EM, pla and ish ea. Its sensors recorded a fast swing from a cold pre-dawn surface environment to a much warmer afternoon one, repeated sol after sol. A sol is a Martian day, about 39 minutes longer than an Earth day. That swing is the engine. Frost does not require a wet Mars. It requires vapor, a cold surface, and enough time in darkness. The word frost hides two different materials. Water frost is frozen H2O. It can form when the surface cools below the frost point for the tiny amount of water vapor in the air. It is the closer cousin to frost on Earth, but the setting is not Earth-like. The air is too thin, and the supply of water vapor is too small for a familiar wet morning. Carbon dioxide frost is different. It is frozen atmosphere, dry ice made from CO2. On Mars, carbon dioxide is the main gas in the air. When conditions are cold enough, the air itself can freeze onto the ground. CO2. Frost is not snow in the everyday Earth sense. It does not melt into liquid water under normal Martian surface pressure. When sunlight returns, it usually sublimates, changing straight from solid to gas. The strongest ground-level case comes from Phoenix, which landed in 2008 at 68 degrees north in the Martian Arctic. Phoenix did not find a warm, damp world. It found a cold soil surface above shallow ice. When the lander scraped trenches, bright material was exposed and then faded over several sols, behavior consistent with water ice sublimating into the air. Its oven experiments also detected water released from icy soil. The lander's images showed frost on and near the surface in the high-latitude environment. That observed, frost is established. It was not inferred from a model alone. Phoenix also carried sensors that watched the air and soil exchange electrical and thermal signals. Those data have been interpreted as evidence for near-surface water vapor changing through the day and night, and for adsorption, where water molecules cling to grains of soil without making liquid water. That exchange is supported, but the exact local cycle is still uncertain. The measurements show movement of water between soil and air. They do not turn the Phoenix site into a place with dew, puddles, or rain. The question is not whether Mars has frost, it is which ice appears, where it appears, and how quickly the sun erases it. Orbiters supply the wider pattern that one lander cannot see. Mars Reconnaissance Orbiter has watched seasonal surface changes, polar terrain, and frost-related activity from above. Other orbital instruments add temperature and composition. The seasonal carbon dioxide caps are established. Each winter, CO2 condenses out of the atmosphere onto the polar regions. Each spring, it returns to gas. Measurements from orbit have tracked the mass and thickness of that seasonal deposit as it grows and retreats. Water frost has a different map. Thermal and visible observations have identified bright blue-white surface patterns that were too warm to be carbon dioxide ice. Those detections place surface water ice or frost as far as about 21.4 degrees south and 48.4 degrees north. And the best interpretation is that much of it is seasonal rather than a nightly coating. The strangest part of the night is the carbon dioxide frost near the equator. Measurements from the Emirates Mars Mission monitored surface water ice and carbon dioxide ice over nearly one Martian year. They found equatorial CO2 frost forming in the second half of the Martian night around the equinoxes, then sublimating at sunrise. That does not mean the Martian equator becomes snowy. It means that, under a narrow set of temperature and time conditions, a thin layer of frozen carbon dioxide can appear on the night side and vanish almost immediately after sunlight arrives. The observation matters because it shows how active the dry atmosphere still is. Mars can move material without rivers, rain, or clouds that look familiar from Earth. At night, the planet can briefly store part of its air on the ground. At the poles, sunrise does more than erase frost. It can reorganize the surface. A seasonal slab of carbon dioxide ice can trap sunlight below it. The ground warms underneath. Gas pressure builds. When the gas escapes, it can carry dust and carve dark fans across the ice. Orbital mapping of the southern seasonal CO2 cap has interpreted dark fan-shaped deposits as the products of springtime jet activity and winds during sublimation. The ice does not behave like a quiet blanket. It becomes a temporary surface machine powered by returning sunlight. Polar night observations have also been interpreted as carbon dioxide clouds whose particles can fall as diffuse snowtails, sometimes adding CO2, ice, dust, and water ice to the surface. That is still Martian carbon dioxide weather, not Earth winter translated onto another planet. Frost invites the wrong conclusion if it is treated as a symbol instead of a measurement. Observed frost on Mars is established. Nightly exchange of water vapor between air and soil is supported by lander data and by models, especially at cold high-latitude sites. The exact balance between adsorption, ice, vapor, and local soil chemistry remains uncertain. Transient brines require even more care. Salts such as perchlorates can lower the freezing point of water, and one proposed pathway links frost to possible salty liquid under special conditions. In June 2025, Nature reported an article titled "Perchlorate Brine Formation from Frost at the Viking 2 Landing Site." That is a claim about a possible process, not proof that Mars has wet mornings. Any brine would be local, temporary, chemically harsh, and contested as a stable surface feature. Frost alone is not evidence for life. By sunrise, the night's record is already being removed. Water frost can sublimate back into the air or remain as part of a seasonal deposit where the cold lasts. Carbon dioxide frost can return directly to gas, sometimes quietly, sometimes violently enough to move dust above polar ice. The answer is that Mars freezes both water and carbon dioxide out of its night air, depending on place, season, and temperature. Most of it disappears because the same thin atmosphere that lets the ground cool quickly also lets sunlight heat the surface quickly after dawn. What remains open is the small-scale accounting, exactly how much water moves into soil grains, how much returns to the air, and where salts might briefly change the chemistry. That would take repeated local measurements of vapor, soil temperature, salt content, and frost through many nights. Frost on Mars is not a sign of comfort. It is a sign that a thin, cold atmosphere is still working. That's why Source. If this was worth your time, like it, share it, and tell me in the comments what you want examined next. If you would like to support this work, the Patreon link is in the description.